Welcome back everyone. In our course on Python for data science, in this lecture we'll discuss about sequence data types in Python. Today we will explore about sequence data types, what are the different ways to store multiple values in an organized and efficient manner. First, let's understand what sequence data types are. The sequences allow you to create or store multiple values in an ordered fashion. In Python, there are several types of sequences, such as strings, Unicode strings, lists, tuples, arrays, and range objects. On the other hand, dictionaries and sets are considered non-sequential data types, which we'll also cover in this lecture. Let's start with strings. A string is a sequence of one or more characters, which can include letters, numbers, and symbols. Strings can be either constants or variables, and they are immutable sequences in Python. To create a string, you can enclose a sequence of characters within single quotes, double quotes, or triple quotes. Here's an example of creating a string. We'll create a string sequence called string_sample and assign it the value learning by enclosing the characters within double quotes. To print a string, you can simply use the print function. When we print string sample, we'll get the output learning. So, string sample is now a string data type in Python. Let us move on to the next sequence data type, which is called a list. In Python, you can create a list by placing the sequence inside square brackets. For example, here I'm creating a list sequence called lst_number, and it will contain only numbers. For example, lst_number equals 1, 2, 3, 3, 3, 4, 5. In this example, you'll notice that we have an element that is repeating, meaning we have duplicate values. Lists can contain duplicate values with distinct positions, and multiple or duplicate values can be included as a sequence when creating the list. Let's print the list and see the output. You will see the output has values 1, 2, 3, 3, 3, 4, and 5, and a single list can contain data types like integers, strings, and objects. Lists can contain elements of multiple data types, and they are mutable, which means they can be altered even after their creation. Now, I'm creating another list sequence called list_multiple type, which has both numbers and strings containing multiple types of data. For example, list multiple type contains 1, 2, B, David, and 2, so it has multiple data types. One advantage of using lists is that you can have elements of multiple data types within a single list and can be altered later. Let us explore array now. An array is a collection of items stored at contiguous memory locations. We can use arrays to store multiple items of the same data type together. In Python, arrays can be created by importing the array module. Let's import the array module using the syntax, from array import asterisk. We have imported everything from the array module using the symbol asterisk, so that we can use the array functions without explicitly calling specific functions. The syntax for creating an array using array function is, array, data_type, value_list. We need to specify the data type as the first argument and the value list as the second argument to the array function. Let's see how to create an array using the array function. Here, we have specified the data type as I, which is for integers, and provided the values as a list, 1, 2, 3, and 4. The output is stored in the object array sample. Now, let's print the values of the array. If you use print, array_sample, it will just print the input you provided. To print the values of the array, we use a for loop to iterate over the elements. In the first iteration, it will print the first value, and the loop will continue to the next iteration until all values are printed. So the output will be 1, 2, 3, and 4. This is how we create an array. As you can see, the array we created is a one-dimensional array. We will see how to create and work with multi-dimensional arrays also in an upcoming session. To remember, as we specified the data type as I for integers. Similarly, if you want to create an array with different data types, you can use the notation to denote different types. For example, if you want to create an array with the data type float, you can use the code f. Moving on, we'll discuss another sequence data type called tuple. A tuple in Python is similar to a list, but the key difference is that we cannot change the elements of a tuple once it is assigned, whereas in a list, elements can be changed. The tuples are created by placing all the elements inside parentheses, separated by commas. For example, tuple_sample equals 1, 2, sam, and 2. Here, we have separated all the values or elements by commas. A tuple can have any number of items, and they can be of different data types also. In the above example, tuple_sample contains integers as well as strings. Tuples can also be created without using parentheses, which is known as tuple packing. Here's an example. In this case, we have not used parentheses to create the tuple, but we have provided the values separated by commas. If you print the value of tuple_sample, this is how it will appear all items within the parentheses. This method of creating tuples is called tuple packing. Next, we'll cover the creation of dictionaries in Python. Before looking at how to create a dictionary, let me explain what a dictionary is. In Python, a dictionary is an unordered collection of data values, which is used to store data values like a map. Unlike other data types that hold only single values in an element, a dictionary holds key-value pairs. Key-value pairs are provided in the dictionary to make it more optimized. A dictionary can be created by placing a sequence of elements within curly braces and separating the key-value pairs with commas. For example, here fruit is the key, and apple is its corresponding value. Similarly, subject is the key, and math is its value. The values in a dictionary can be of any data type and can be duplicated, but the keys must be unique. For example, dict_sample here, fruit 1 is the key, and apple is its corresponding value. Similarly, fruit 2 is the key, and apple is its value. So, we can see that though the values are same but we have to give the different key. Dictionaries can also be created using the built-in dict function. An empty dictionary can be created by placing elements inside curly braces, or by using the dict function. Here's an example of creating the same dictionary using the dict function. Dict_sample equals dict, key 1, value 1, key 2, value 2. In this case, we have provided the key-value pairs as tuples to the dict function. If you print the dictionary, you will get the keys and values. Next, we will discuss about sets in Python. So, a set is an unordered collection of unique elements. Sets are used to store multiple items in a single variable, similar to lists. However, unlike lists, sets cannot have duplicate values, and the elements within a set are not ordered. Sets are defined using curly braces or the set function. Here's an example of creating a set using curly braces. In this example, fruits is a set containing 3 elements, apple, banana, and cherry. You can also create a set from a list or any other iterable object using the set function. For example, in this case, if we print the variable number, the output will be 1, 2, 3, 4, 5. Note that even though the list contains a duplicate value, 4, but the set numbers only contains unique elements. Sets support various operations like union, intersection, difference, and symmetric difference. These operations can be performed using operators or set methods. Here are some examples. First, we will create 2 sets, set 1 and set 2. If we print the result of union operations, the output will be 1, 2, 3, 4, 5, and for intersection operations the output will be 3. The output of difference operation on the set will be 1 and 2, and similarly the output of symmetric difference operations will be 1, 2, 4, and 5. Sets also support various methods like add, remove, discard, clear, and more. These methods allow you to add or remove elements from a set, clear the set, or perform other operations. For example, we create a set name as fruits with 3 items like apple, banana, and cherry. To add an element, we use keyword add to the set, and to remove an element, remove keyword is used. And for clearing all the elements from the set, use clear function. Additionally, we can also use the in operator to check if an element exists in a set, and the len function to get the number of elements in a set. Sets are particularly useful when you need to deal with unique elements or perform set operations like unions, intersections, or differences. They provide an efficient way to store and manipulate collections of unique items in Python. The next thing we will discuss is range. The range function in Python is used to generate a sequence of numbers. It is commonly used in loops to iterate over a specific range of values. The range function returns an immutable sequence type called range object. The syntax for the range function is range, start, stop, step. Here's what each parameter means. Start parameter is optional, specifies the starting value of the sequence. If not provided, the default value is 0. Stop specifies the ending value of the sequence. The sequence will include values up to, but will not including, this value. Again, step parameter is optional, an integer that specifies the increment or decrement if negative between consecutive values in the sequence. If not provided, the default value is 1. Let's look at some examples. Example 1. In this example, range 5 generates a sequence of numbers from 0 to 4, not including 5. The for loop iterates over this sequence, and each number is printed using print. The end equals argument is used to print the numbers separated by a space instead of a new line character. Example 2, here, range 2 and 8 generates a sequence of numbers from 2 to 7, not including 8. The for loop iterates over this sequence, and each number is printed with a space separator. Example 3, in this example, range 0, 11 and 2 generates a sequence of even numbers from 0 to 10, not including 11. The third argument 2 specifies the step size, which means it increments the value by 2 in each iteration. The for loop iterates over this sequence, and each even number is printed with a space separator. Example 4, here, range 10, 0, and -1 generates a sequence of numbers in reverse order, starting from 10 and going down to 1, not including 0. The third argument -1 specifies a negative step size, which means it decrements the value by 1 in each iteration. The for loop iterates over this sequence, and each number is printed with a space separator. The range function is particularly useful when you need to iterate over a specific range of values or perform operations a fixed number of times. It is commonly used in for loops, list comprehensions, and other situations where you need to generate a sequence of numbers. One important thing to note is that the range function returns a range object, which is an immutable sequence type. If you need to create a list or other mutable sequence from the range object, you can use the list function or list comprehension. The range function is a built-in function in Python and is widely used in various programming scenarios where you need to work with a sequence of numbers. It provides a simple and efficient way to generate a range of values, making it a valuable tool in Python programming. So, in this lecture, we learned about sequence data types in Python and explored some of the commonly used sequence data types that can serve as containers to store data. We covered strings, tuples, lists, arrays, dictionaries, sets, and the range object. For each of these data types, we saw how to create and initialize objects using examples. In the upcoming lectures, we will dive deeper and learn how to perform various operations on each of these sequence data types, allowing you to effectively manipulate and work with data in Python. Thank you for joining us in this lecture. If you found it helpful, please hit the like button and subscribe to our channel for more informative Python for data science content. Your support means a lot and motivates us to create more educational resources for you. Stay tuned for the next lecture, where we'll continue our journey through Python's data science course and unlock its full potential.